Okay, so this is just a recap on how to do energy level diagrams looking at bond energies, looking at the example of methane. So to start with, you need to remember the structure of methane, and that methane is a hydrocarbon molecule. It's got one carbon atom in the middle and it is surrounded by 4 different hydrogens. Knowing the structure is quite important for you to be able to work out the bonding and therefore the bond energies. So you need to start off by writing out the balanced symbol equation for the reaction. So we start off with the formulae. So we're starting off looking at methane plus oxygen is going to make carbon dioxide plus water. At this point you should be able to see that the equation is not balanced. Hopefully you've noticed that we've got 4 hydrogens here and only 2 here, and that we have 3 oxygens here, and in total we've got 2 oxygens there, and in total we've only got 3 on the other side. So we need to sort that out. So we need to balance this equation, and we balance it by popping a 2 in front of the water and a 2 in front of the oxygen. It now helps to draw out the displayed or the structural formulae to show what's actually happening and what the bonds are, because you're going to need to calculate the different bonds. So it's important to know what the bonding is. So our methane molecule has got a carbon in the middle and it's surrounded by 4 different hydrogen atoms, each joined by a single covalent bond. Our oxygen is an oxygen-oxygen double bond, and we're going to carbon dioxide. It's got a carbon in the middle and it's actually surrounded by 2 double bonded oxygen atoms. And then our water, we've got our oxygen with single bonds to 2 hydrogens. So now we need to work out how many bonds are breaking and how many bonds are forming. So I'm just going to put a line down where the reaction actually happens. So the bonds breaking, well, in this molecule, in the methane, we can see 1, 2, 3, 4. They're all the same bonds because they're all between 1 carbon atom and 1 hydrogen atom. So therefore I only have carbon-hydrogen bonds, and I have 4 of those. Now if I look at my oxygen, I've only got the 1 bond, and this is a double bond. So I've only got that 1 oxygen-oxygen bond. And these together are all of the bonds that need to break. So these are the bonds breaking, and this is the activation energy. Remember that the activation energy is shown by a capital E and a little a. Now I need to have a look at the bonds that are forming. So if I look at my carbon dioxide molecule, I have 2 bonds forming. They're both between carbon and oxygen, and so they're exactly the same. So I have a carbon-oxygen double bond, and there are 2 of those. I now need to have a look at water, and water has got, again, 2 bonds, each one between oxygen and hydrogen. So it's only oxygen, hydrogen single bonds, and I've got 2 of those in each molecule. And these together are the bonds forming. Now, what I have not done so far, I have not taken into account the balancing of the equation. So where I've got 1 bond forming in my oxygen molecule, I actually need to take into account that there are 2 oxygen molecules. So this 1 gets changed to a 2. In total, there are actually 2 bonds that are forming. Likewise, I need to do the same with my water. So you can see here there are 2 waters, so I need to change this 2. I need to actually double it up, and that becomes a 4. Now all of this needs to go onto an energy level diagram. So I need to start off by looking at where my reactants go. So my reactants in this case, I've got my methane and I've got 2 oxygen molecules. I also now need to think about what is going to happen. So to begin with, energy is going to go in. So I'm going to have an increase in the amount of energy. This is our activation energy. And what's happening up here is I actually have all of the separate atoms. So I need to think about, I'm going to have 1 carbon atom plus 4 hydrogen atoms. Notice it's not H2 because they're separate atoms, plus 4 oxygen atoms. I now need to think about the energy coming out. So the energy is going to come out when the new bonds form. And that energy coming out, now I know that burning methane is an exothermic reaction, so I'm going to draw my arrow going lower than my reactants. And I'm going to draw a line for my products. So here I have reactants, and over here my products. And my products in this case are carbon dioxide plus 2 water molecules. Now we'll leave this here for now, and we're going to come back to this in a minute, but what we need to do is we need to actually calculate the amount of energy that our blue arrows here represents. So what we need to do is we need to look at the amount of energy that's in each individual bond. So starting off with our bonds breaking. So I'm going to look at the bonds that are breaking, and I had carbon-hydrogen bonds, and there were 4 of those. I had oxygen bonds as well, and there were 2 oxygen bonds. Now this is where we assign values to these bonds. So my carbon-hydrogen bond has a value of 413 kilojoules, and my oxygen bonds, each one has a value of 498 kilojoules. Therefore, I can insert the values for kilojoules in the place of the bond that I've written. So when I'm looking at the breaking, I'm going to be writing 4 times 413. So that's my carbon-hydrogen. So this is the carbon-hydrogen bonds. And I need to add that together with 2 times 498. And that's my oxygen-oxygen double bonds. And overall, this should give me 2,648 kilojoules. So 2,648 kilojoules of energy. So I've multiplied first of all before I've added together. So I've done the brackets first. This is the energy that is needed in order to break the bonds to start the reaction. So I can now go back and I can have a look, and I can add on here, and let's add it in green. So I'm adding on here that I've got 2,648 kilojoules, and that is my activation energy. So now I need to look at the energy that's coming out when I make the new bonds. So let's have a look at making. And when I'm making the bonds, I'm looking at 2 lots of carbon-oxygen double bonds, and I'm looking at 4 lots of oxygen-hydrogen bonds. So my carbon-oxygen double bonds each have a value of 805 kilojoules, and my oxygen-hydrogen bonds have a value of 464 kilojoules each. So again, inserting that into the equation, I have 2 lots of 805 plus 4 lots of 464, and overall that should equal 3,466 kilojoules. So going back to my energy level diagram, I can again add that value in. So I'm looking at 3,466 kilojoules. So now I've got my energy level diagram, and I know what's happening when I break the bonds and what's happening when I form the bonds. So breaking the bonds here, forming the bonds here. But what I'm interested in what is happening overall. And that should be a simple take the difference between them. So I'm going to do the energy out. So the energy out minus the energy in. And so this is 3,466 minus 2,646. And in total that equals 818 kilojoules. So there have been 818 kilojoules that have come out of the chemicals and have ended up heating the surroundings. So this reaction is exothermic. So I can now pop this 818 kilojoules of energy here. And you can see, compared to the amount of energy that went in and the amount of energy that came out, this isn't actually that much energy. And this is why I can burn methane bubbles quite happily on my hands.